Good day to you, my viewers, and thank you for picking to watch this tutorial video. This is about electrophilic addition reaction. Okay, electrophilic addition reaction. So, first of all, we must know that it's an addition reaction. Addition reaction. You are familiar most likely with the fact that if you have an alkene, if you have an alkene and you are adding HBr to that alkene, you are familiar with the fact that people just usually use their sites to divide the molecule into two and say that, and then you divide these into two as well and say that H will come somewhere and then Br will come to the other side. So you have H, H, and then H, H, Br. Now this is actually a hydrohalogenation reaction, hydrobromination in this case. However, we must be familiar with the mechanism behind this kind of a reaction. So, what is actually happening? What is actually happening? So, here is the alkene, that's the ethene, and then you have the HBr. There's the HBr molecule being added to it. One thing about addition reaction is that they are to give you a single product. If it was a substitution reaction, it will give you two products. So, as in an addition reaction, particularly, what happens? Where is the first thing you try to find out is the electron-rich region. Okay, the electron-rich region, and this portion is electron-rich. This portion, because of the double bond that you have there. Of course, you have you have a sigma bond. You have a sigma bond here. You have a sigma bond, and you have a pi bond. The sigma bond is held strongly. The pi bond is held loosely. Okay, so not as much as this one is strongly held in between the two carbon atoms. So because of that, the pi bond is always available to participate in reactions. So what happens? What happens here? The electron-rich region goes to attack here. But before the attack, can I quickly explain that the hydrogen here is connected to bromine, which is electronegative. And because it's electronegative, this is electronegative. And then this is going to draw electron more towards itself. Okay? It's going to draw electron more towards itself, and it's going to draw electrons more towards itself because it is electronegative. And then this one is positive, partially electropositive. So because electrons are being drawn away from it. So technically you have delta positive here and delta negative here. So this is a negatively charged region. The electron is negatively charged, which I want to ask you so that you can participate in what I'm doing. I think I should, after this explanation, I think I need to write this again so that I will have a clean screen. So that I will have a clean screen. So I'm writing this again. So I have the alkene here. The alkene is right here. Okay, and I have the HBr here, and this is delta negative, delta positive. I believe that is clear. And this is the electron rich region. So which part of this molecule do you think the negatively charged electrons will attack? It is negative. It will want to attack the positive side of this molecule. So how does it do that? A curly arrow. Okay, so as the curly arrow goes, um, what happens is that you have you have this kind of outcome. So the curly arrow has gone. That means the pi bond has gone to attack the hydrogen of the hydrogen bromide. Okay, so we no longer have the pi bond. We only have the sigma bond remaining here, and this. Okay, and then now believing that it was the first carbon that the bond decides to stay on. So it stays on that bond, on that first carbon, and attacks this. Actually, this arrow means a proposal. This arrow is a proposal. The carbon here is saying, hydrogen, I want to form a bond with you. So a proposal, a proposal. Carbon wants to form a bond with hydrogen. Okay, so what you now have as an outcome is the hydrogen coming here. But that's not all. As this is happening, as this is happening, uh, this is forming a bond with this. But if you look at hydrogen, hydrogen cannot accommodate two covalent bonds at the same time. No, the maximum number of electrons you can have around hydrogen is what? 2. So this bond must break. So the 2 electrons here fold to come and stay on bromine. So that means this bond is broken. So what do you now have as a result? So you have hydrogen staying here. You have hydrogen staying here, and you have hydrogen staying here, and you have um, you have hydrogen staying here, and the other carbon now has only 2 hydrogens on them. Now you would understand again that the pi bond that attacked here, that attacked the hydrogen, was donated by both of the carbons. But now the hydrogen that was attacked, in fact, this must be this more in fact this must be depicted in red, so that you remember that it was the red arrow that was shown here, so that you can remember that it was the red arrow that was shown here that formed this bond. So now, because of the formation of this bond now with this carbon, this other carbon, which also contributed to the covalent bond that is in this red ink, has technically lost the electron that it contributed, to form that pi bond that was up here initially. So it has lost it. So technically, since it has lost one, we put a positive sign. On it. And whenever you have this kind of a structure, you call it a carbocation. It's called what? A carbocation. All right. Now, but what is the fate of the bromide ion that has been formed up here? These are the two. This is the pair of electron that is on top of it, and then it carries a negative charge. Is actually carrying a full negative charge now. So now, because of the lone pair, this pair of electron that it's carrying here, it's very possible for it to just come and attack this carbon that is positively charged here. Okay, so as it's attacking that carbon that is positively charged in this carbocation, you end up with a final product. And the final product is you have carbon, carbon, you have three hydrogens around this carbon, and then you have two hydrogens, and then the bromine that attacks now gives us the bromine here. So you call this kind of a reaction an electrophilic addition reaction. You see that we ended up with a single product, electrophilic addition reaction. I hope this video helps you to understand what usually happens when we are trying to add some reagents across the double bond in organic chemistry. Thank you for watching this tutorial video, and see you in my next video.